Problem 1. Find dy dx if y equals the natural log of the square root of x squared plus 2 all over x minus 5. Before taking the derivative, I am going to simplify this as much as I can. The first thing that we can do is actually separate the problem into two parts with a minus sign because we do have subtraction. The second thing that I'm going to deal with is the square root because remember it's a 1/2 power and I can bump the 1/2 power out front. So I'm going to make this say y equals 1/2 natural log x squared plus 2 minus natural log x minus 5. Now from here we can take the derivative, and if I have an ln, if you remember the little thing that I always put on the board, we've got the natural log of u and we've got du over u. So since I'm at natural log of u, we want to use du over u. For this first part right here, my u is x squared plus 2. So when I take the derivative, the 1/2 is just going to bump along. This will be du, so the derivative of u will be 2x over u, which will be x squared plus 2. And then minus, on the second part, this will be the u. And again, since I have ln u, my derivative will be du over u. The derivative of x minus 1 is 1. X minus 5 is 1, excuse me. And then u will be x minus 5. I can do a little bit from here. First of all, these 2's can cancel. So my derivative will be x over x squared plus 2. And then minus 1 over x minus 5. And then I am going to go ahead and get a common denominator for these two, which would just be both of them put together. I'd have x squared plus 2 times the quantity x minus 5. This first one I'd have to multiply the top and the bottom by x minus 5. So I'll get x squared minus 5x. And then the second one I'd need to multiply it by x squared plus 2. Remember this minus sign is going to carry along to both parts, so this will be minus x squared minus 2. I notice that my x squareds are going to cancel, so my final derivative will be negative 5x minus 2 all over the quantities x squared plus 2 times x minus 5. Problem 2, again, find the derivative. This time f of x equals the natural log of the absolute value of secant x. Please remember that if we see absolute values, we can just actually turn them into parentheses. And again, since I see ln u, we know that we want to do du over u to get the derivative. So u is going to be our secant. So when I take the derivative of this, it will just be du. The derivative of secant is secant x tangent x, and if you don't know that, go study your cards. And then u is secant x. And then notice my secant x's will cancel, so my derivative will just equal tangent x. Right, problem 3, differentiate, which again just means find the derivative. And we are given that f of x is equal to x squared times the quantity ln x squared plus 2, okay? On this one, what we're going to do, we're not going to separate it with adding or anything like that because the ln is only on the second part. I would actually want to put a times sign there. So this is going to be the product rule, so this will be f and this will be g. To get f prime, the derivative of x squared is just 2x. To get g prime, again, this is an ln u problem, and if I have ln u, I would like to make it du over u. So this will be my u. Du will be 2x, because that's the derivative of x squared plus 2, and then over u, which would be x squared plus 2. Okay, so now I have all my parts. I'm ready to actually find the derivative using the product rule. It's going to be f prime times g, so 2x times the natural log of x squared plus 2, and then plus f g prime. X squared times 2x over x squared plus 2. Okay, now from here I could actually simplify it before I started going, but I'm actually at this step going to notice that both parts, since they're separated by plus, both parts have a 2x, so I'm actually going to factor out a 2x from the problem. And when I do that, I'll get natural log of x squared plus 2 plus x squared over x squared plus 2, and then I'm going to leave my answer just like that. I do not cancel out these x squared plus 2's because the x squareds, because the one on the bottom is involved with the plus 2.